Hi, my dears. Today we'll be discussing the index questions that are given in page number 150 on the topic refraction. The first question is a ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal, and why? So we'll have to analyze how much mark will this question carry. This question can carry maximum of 1.5 to 2 marks. So accordingly, you will have to write your answer. If in case it is carrying 2 marks, you can draw a very rough sketch of this diagram also. But mostly this cannot have more than 1 mark or 1.5 marks. So here you will have to mention, see what all are the points or the key points which the examiner will be looking at. See, here a ray of light traveling in air enters obliquely into water is what it is given. So the question is that does the light ray bend towards the normal or away from the normal? So the examiner expects you to say whether air is a rarer medium and water is a denser medium. So you will bring the sentence here: when light traveling in air, which is a rarer medium, enters obliquely into water, which is the denser medium, the ray of light bends towards the normal. Why is it bending? It is because the refractive index of water is greater than air. So we learned about this. When the light enters from obliquely from a rarer medium to a denser medium, the light ray will bend more closer towards the normal. Instead of tracing a path like this, it will bend more closer towards the normal. So why is it so? It is because the refractive index of water is greater than air. In other words, you can say this is a denser medium, so the speed of light in water is less than the speed of light in air. And this is a statement that you'll have to remember whenever a question is asked in the topic from the refractive index topic. Whenever the optical density is high, which means the refractive or any denser medium will be having a higher refractive index, and whenever the medium is having a higher refractive index, the speed of light is lower there. We already discussed this phenomenon where the light ray that enters from the rarer medium and reaches your eye. So as it enters, as this pencil is from the area, the pencil is immersed in water, you tend to see the pencil as cut or broken from the point at the point of interference. Why? Because the light ray is bending towards the normal. Why? The speed of light is less in water, due to which you get to see the light ray coming from a different direction, which gives the illusion that the pencil is cut at the interference of water and air. The second question: light enters from air to glass having a refractive index of 1.50. What is the speed of light in glass? The speed of light in vacuum is 3 into 10 raised to 8 meters per second. So when a question is asked like this, what is your approach? This can carry a maximum of 2 marks. So what is given in the question, you will have to write. Then you will have to write the equation, the approach that you are going to, how you are going to approach this question. And then you should have the concluding statement mentioning the final answer that you have got by solving the equation. So given is the refractive index of glass is 1.50. And now you have to tell the examiner that I know what is refractive index of glass. So what is refractive index of glass? It is the speed of light in glass with respect to the speed of light in air. So you write this with a simple equation. And now here you want to derive your own equation. So you call the speed of light. This is what we have to find. We have to find the speed of light. in glass. So if x is the speed of light in glass, so you put your values here, and the refractive index Ng of glass is 3 into 10 raised to 8 meters per second divided by x, which is 1.50. That is the refractive index given in the question. And now you solve for x and you get the value is 2 into 10 raised to 8 meter per second. So then you have the concluding statement. Therefore, the speed of light in glass is 2 into 10 raised to 8 meter per second. Remember the three areas that the mark, your mark is allotted. This statement has carries mark. This, of course, approach will be having the greater marks, and your final concluding statement do carry marks. This question can come for 2 marks. The third question, find out from table 9.3 the medium having highest optical density. Also find the medium with the lowest optical density. These kinds of questions rarely do appear in your exams, but you will have to, when you do these questions, you will get the concepts very clear and thorough. The absolute refractive index is what? It is the refractive index of a medium with respect to the speed of light, or that is the speed of light in the particular medium, or say if it is glass, it means glass with respect to the speed of light in air. So that is what refractive index. So it is they have done the specific values are given in the table. So now you will have to find out from the table which has the highest optical density. So here, if you see, the refractive index of air is 1.0003, which is quite less, less. And the refractive index of diamond is 2.42. So whenever this statement you will not have to write, but even if you write, it is fine. Optical density of a medium is higher, means the refractive index is higher. When it is denser, it will more the extent of bending. That is, refractive index is nothing but the extending of bending of a light ray towards the normal. So refractive index is the extent of bending in simple terms. So optical density is higher means the extent of bending is higher. That is, the refractive index is higher. So the speed of light is less. So the medium with the highest optical density is diamond, as the diamond has the highest refractive index. And also find the medium with the lowest optical density. So the lowest optical density will be for air. So in a way, you are trying to say the speed of light in air is the highest. See, speed of light in a say we know speed of light in air is in vacuum is 3 into 10 raised to 8 meter per second. That is, the light travels the distance of 3 into 10 raised to 8 meters in 1 second. Okay, so the time is a constant there. So when the refractive index, or when the speed of light is more, means what? We have learned in your previous classes what is speed? The distance traveled in unit time. So what is the unit time when I say the speed of light in air? It is the distance of the light travels in air upon 1 second, in 1 second. So the time is taken as a constant, which means what? When the speed of light is high, means it will travel more distance. When the speed of light is less, means it will travel less distance. Okay, just keep this in mind. This concept could be will be better understood if you know why when the speed of light changes, what does subsequently changes the distance traveled. When the speed of light is more, means the distance traveled will also be more. When the speed of light is more, it will move away from the normal, and the distance traveled will be greater. While the speed of light is less, means the distance traveled will be less, and also the light will be bending more closer towards the normal. So have this concept very clear and thorough. The fourth question is also based on the table. So you are given kerosene, turpentine, and water. So what is the refractive index of water? 1.31. Kerosene, you saw it as 1.44. Turpentine, you saw it as 1.47. So the refractive index is more, means what? The optical density is more, which means the speed of light is less. So you'll have to say the light travels the fastest in. So the light travels the fastest where? the refractive index is the lowest. So the light travel, the faster is water, then it goes to kerosene, and then it goes to turpentine. So the fastest is water, then kerosene, and then turpentine. See, always remember, optical denser medium doesn't have to be denser in the mass also. When you will see oil and kerosene floating above the water, but that doesn't mean it is optically uh, rarer. The mass density is less for kerosene and oil, but it is not optically rarer. Okay, those two terms shouldn't get confused. Optical density is necessarily not, it is necessarily not always in relation with the mass density. Then the fifth question, the refractive index of diamond is 2.42. What is the meaning of this statement? Analyze your question. The refractive index of diamond is given as 2.42. What is the meaning of this statement? In a way, the examiner is asking you, define to me what is refractive index. Okay, and now tell me what is the relationship between this refractive index and the speed of light. Okay, so first you will define refractive index. So what is refractive and what is refraction? First of all, when the light ray travels from obliquely from one rarer medium to an optically denser medium, it bends towards the normal. The refractive index refers to the extent of bending of the light ray towards the normal, and refractive index of a medium is given by the equation. So whenever there is an equation in the related topic, mention that equation always. And if you can highlight it, do highlight it. But even if you write it legibly and clear, it is more than enough. So define the refractive index, then go for the equation of the refractive index, and then say the concluding statement. So you already told the refractive index of a medium is the speed of the light in the medium with respect to the speed of light in air. So speed of light in air could be compared to C. So here you will have, when you write an equation, you will have to define the terms where Nm is the refractive index of the medium, C is the speed of light in air, and speed of light in medium is V. You will have to define the terms on your right hand side. So, and then you come to the question, the refractive index or the extent of bending towards the normal of diamond. Even if you cut out that statement, it is fine. The refractive index of diamond is 2.42. It is high. It means the diamond is an optically denser medium, and so the speed of light in diamond is very less. Okay, the examiner is looking for you to bring that that relationship between refractive index, to define the term refractive index, bring out the equation and then compare it with the speed of light and what you observe with the when it is given that the diamond is having a refractive index of so and so, you will have to immediately connect that the speed of light in a diamond is very less. So here we wind up with the 5 index questions on the topic refraction. And the next topic, next session, will be going into the refraction by spherical lenses. Thank you, guys.